Okay, so we're going to do ratio. We're going to take 2 days to do this ratios and proportions. And then actually the next day after that is going to be some percentages. How many remember doing percentages? Okay, you've had it. And unfortunately, it's actually not even in our curriculum so much to do percentages. But you know, when you think of the things that are like useful to your life actually, is for you to understand percentages. Because they come up and they're very meaningful, whether it's like how much you pay for your house, how much you save in your check or your tax rate or whatever. I mean, it's all about percentages. So to me, it's kind of a disservice to not emphasize this more. Okay, go ahead, Lily. So a ratio uses division to compare two numbers. So normally, you know, you're going to see most of the time it's a fraction, right? And the fraction bar itself means division. But it's sometimes not. Sometimes they'll say in words like, you know, A is to B as C is to D. 1 is to 4 as 2 is to 8. Right? They're not using it like with a fraction format, but it kind of means the same thing. And they could even use a colon between the two. So instead of saying A divided by B, they could say A colon B, and that's still a ratio. I mean, you don't see it often. By far, we need to know the fraction format. So notice that the word ratio is same as rational, right? We said rational numbers are what? Okay, better answer than that? Better answer than that? Fractions. Any number that could be turned into a fraction. So ratios are fractions. Rational numbers are fractions. Ratio, rational. I mean, it's kind of the same root word there. I mean, we struggle with this thing even in like the higher classes. If I ask my Algebra 2 trig or even a math analysis class, I could say, what's a rational number? Believe me, they'll struggle just like you might struggle. Even though the root word should just kind of be a giveaway. Rational, ratio, that's a fraction. Okay. So here, these are just basic examples of ratios, right? A volleyball team plays 14 home matches and 10 away matches. Find the ratio of home matches to away matches. Again, and we can just use a fraction, right? What is the ratio of home? Home to away is 14 over 10. Okay, but here's the thing. You have to simplify, right? We wouldn't leave 14 over 10 would not be the 100% best answer. What's a simpler version of that fraction? You could divide a 2 out, right? Now, what if you're not good at doing that? What else could you do? Put it in a calculator, right? Put in 14 divided by 10. Right? Go over to the main screen in your calculator and go 14. I mean, I think if you go, let's go fraction format, right? Alpha y equals 1 and put in 14, arrow down, 10, and then hit enter. And it reduces the fraction, 7/5. So don't leave a fraction which could be simplified, unsimplified. Okay, find the ratio of away matches to home matches. So how's that different than what we just answered? We flipped it, right? Now we're saying we're going away matches to home, so now we got to put the 10 in the numerator and the 14 in the denominator, which gives us 5/7. Okay, what about the ratio of home matches to all matches? So the total home matches were 14, and it looks like the total was 14 plus 10, 24. So let's put in a 24. And then simplify the fraction. What do you got? 7 over 12. Good. Easy problems, right? Okay, you try this one. Derek and his brother decide to combine their CD collections. Derek has 44 CDs, his brother has 52. Find the ratio of the number of Derek's CDs to the number of his brother's CDs. And then find the ratio of the number of Derek's CDs to the total. Does anybody in here still buy CDs? Not too many? You know, this was written in 2006-ish, right? Because we had an old book. What would be a better collection to say? Record albums? How many have record albums? One or two? But I don't think it's like everybody. What's the thing that everybody has? Cassette tapes. You're going to say 8 tracks next.
I do have those.
But at least you know what's a CD, right?
Yeah.
Okay, so you know what it is, so it makes a little bit of sense. But could probably come up with something better than a CD these days. How about downloaded songs? Downloaded songs. Do you download albums? Yeah. Maybe. Has anybody downloaded like 50 albums? More than that? So that might be a better thing to do, you know? It's like. So what's the ratio of Derek's CDs to his brother's CDs? Quiet, please. Okay. What's the ratio of Derek's to his brother's CDs? 44 over 52, but then you got to simplify it.
11 over 13.
Right. Okay. Find the ratio of Derek's CDs to the total CDs.
44 over 96.
So 44 plus 52 is 96. So it should be 44 over 96. And that can be simplified also. 11 over 24. Right? And you don't turn that into a decimal. It just needs to be the simplest fraction you can have. So that's the basics of ratios. A proportion is when you make an equation between ratios. Right? So in pure math terms, A over B equals C over D. That's called a proportion. In any case, it's an equation. It's something to be solved. And why do you think that says B does not equal 0, D does not equal 0? So take your calculator and let's just say take 5 and divide by 0. What does the calculator tell you?
Error.
Right? So when you divide by 0, you get an error because you can't divide by 0. Right? It doesn't make sense to try to divide something into pieces that all have no value, right? So that's why we don't want to have zeros in the denominator. So a lot of times in these kind of equations, if there's something that comes after like that says B does not equal 0, D does not equal 0, don't be confused like that's part of the problem to solve. It's not part of the problem to solve. I mean, I've seen kids turn away from problems completely like that just because they don't understand what that last bit is. It's just trying to say, don't divide by 0. It wouldn't be true. That statement wouldn't be true. Okay. So, if we have a proportion, that is an equation to solve, and on one side the variable is in the numerator, then we can just use what we have already done. This is a one-step problem, right? What do I have to do to isolate the x in this problem? Why is it not isolated? It's being divided by 30. Okay, how do you undo a divide by 30? Multiply by 30. So in one step, you're going to go multiply times 30 there and multiply times 30 there. Okay, on this side, the 30s cancel, and I just have x. Okay, now again, you can do this totally in the calculator. What is 30 times 11 over 6? The answer is 55. Right? If you do it in the calculator, there won't be any work to show. You just say I did it in the calculator. If you do it like without a calculator, what I would do is say, well, look, 6 goes into 30 how many times? 5 times. And so what's left? 5 times 11 is 55. But it's okay if you use your calculator and just do 30 times, bring up the fraction format, 11 over 6. Enter. It's done. So, okay, here's your U try. Solve. Okay, so what did you have to do to isolate the W? Well, multiply by 35, right? Since it's being divided by 35, you multiply by 35, right? That's multiplication property of equality, right? 35s cancel, and then you put all that in the calculator, and you get 20, right? 7 goes into 35 5 times. 4 times 5 is 20. Try that one. Okay, what do you multiply by? 12 times 12. Right, these 12s cancel, and then you put all that in the calculator, and you got what? 54. Right, 2 goes into 12, 6 times 9 times 6 is 54. So proportions can be used. I mean, honestly, if anybody cook here, anybody like use a recipe that it's like it's too big, you want to cut it in half or something like that, or when you do that, you're using proportions, right? You're using proportions. Also, like sometimes people have to like adjust medicines sometimes, like for body weight. Like it's like this is the dosage for, it's why kids have different dosages than adults, basically. Yeah. Well, there's different doses for a big dog and a little dog, So here would be an example of using a proportion to solve like a recipe problem. A recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? So what's the unknown thing here? How many tomatoes, right? So let's make our variable be t for the number of tomatoes, right? So we want to say it like this, right? We want to say it takes 30 tomatoes to make 12 pints. It makes t, which is unknown, to make 4 pints. So 30 is to 12 as what is to 4. So we set it up as a proportion and now solve. How do I solve that for t? How do I solve for t?
4 times 30.
It's being divided by 4, so you need to multiply by 4. Right? 4's cancel. And what do you get when you put all that in the calculator? 10? 10. So let's see. 4 goes into 12 3 times. 30 over 3 is 10. So you need 10 tomatoes if you want to make 4 pints of salsa. Good deal. Okay, try this one. When 2 full moons occur in the same month, the second one is called a blue moon. On average, 2 blue moons occur every 5 years. How many blue moons are likely to occur in 25 years? So again, it's like 2 is to 5 as what is to 25? right? So you set it up as an equation and solve. How do I solve this one? Adam?
Times 25 and you get 50, and then when you divide it by 4, you get 10.
Okay, so multiply times 25. 5 goes into 25 5 times. 2 times 5 is 10. But you could just put it all in the calculator. Yeah, Hunter?
How is 25 times 25?
It's not 25 times 25. B is being divided by 25. So it's actually more like 1 over 25 times 25. It's like 1/25 times 25. And last one from my hometown. The elevator takes passengers from the lobby of the John Hancock Center in Chicago to the observation deck. It travels 150 feet for every 5 seconds. Right? The observation deck is on the 94th floor. It's 1,029 feet above the lobby. So how many seconds does it take to go from the elevator, from the lobby to the observation deck? What's the proportion that we need to set up? What's the unknown? The time, right? So we want to say, I'm saying that because I want to set this up right. You wouldn't be wrong to say 150 over 5, right? 150 is to 5. But we know what we're solving for is actually the 5. It's the time. So we're going to say 5 is to 150 as what is to 1,029. And this one you're definitely going to use a calculator for. 5 is to 150 as what is to 1029. What are you going to do to solve that? Multiply by 1,029. Right? These cancel. And then you got to put all that in the calculator. And what did you get? Should be a decimal of some kind. So you're getting 31.3 seconds.
So it's actually it's 34.3.
Okay. That's not even the tallest building in Chicago. I mean,
It's 34.
is 34. Who said 31?
It's
Okay.
34.3.
Okay. 34.3?
Yeah.
34.3 seconds. Okay. I was in a hotel elevator last week that was only like going to the 4th floor. It seems like it took 30 seconds to go to the 4th floor. And it was new.
I think it took us like
So that's the homework.
30 minutes to get from the 5.